Hi students, welcome to physics class. In electric current, so far we have completed first question, second, third, fourth, fifth. Now we shall see the sixth question in this online class. The question is given: 12 volts battery is connected in a circuit, and to this 4 ohm, 12 ohm resistors are connected in parallel. 3 ohm resistor is connected in series. To this arrangement, draw the electric circuit from this information and find the current in the circuit. So first you have to write what is parallel, what is series. Parallel definition you write: resistors in parallel, the equivalent resistance connected in parallel, its reciprocal is equal to the sum of the reciprocals of individual resistances. 4 ohm parallel to 12 ohm. Like this I have connected in the circuit, and it is in series with 3 ohm. Here we have to find the current flowing through the circuit also. First, 4 ohm parallel to 12 ohm. 4 into 12 by 4 plus 12 is equal to 48 by 16. That is equal to 3 ohms. 3 ohm series with 3 ohm. This 3 ohm is in series with another 3 ohm. So 3 plus 3 is equal to 6 ohms. Ohm's law. According to Ohm's law, V is equal to IR. From that I have to find I value. I is equal to V by R. 12 by 6 is equal to 2 amps. Equivalent resistance in or when connected in parallel, that we mentioned before only. These two we have to mention. Next, seventh question. List out materials required for the experiment. Effect of increasing of cross-section area of a conductor upon its resistance. Write experimental procedure. See, for this, what is our aim? Find the relation between resistance and area of cross-section. Things require: battery, source, conductor which have non-zero resistance, connecting wires, copper wires, ammeter to measure the strength of the current, key, on or off, switch. Now I connected the circuit in two cases. First I have taken small area of cross section, next I have taken large area of cross section. For small area of cross section I have noted current strength using ammeter, and for large area of cross section also I noted the current strength. That I have to mention in the procedure. What I have to mention is a circuital arrangement first. First we will explain how the circuit is built. Next we will explain how current and area of cross section are related, we will mention. From that another statement we will take and we will mention the current and resistance relationship. Here suppose in the procedure, first point I will write the circuital arrangement. I have connected a conductor in series with the voltage source, ammeter, switch. Here in the first case I noted the current strength values. For area of cross section A1, current values I noted is I1. For area of cross section A2, I noted the current reading as I2. Now, as the area of cross section is increasing, current values are also increasing. A2 greater than A1, it implies I2 greater than I1. More current is flowing means it offers less resistance. Less current is flowing means it offers more resistance. That's why R1 resistance is more when compared to R2 resistance. So R2 is less than R1 I got. So it is inversely proportional. This is a conclusion for the experiment. Next, eighth question. Write the required material for the experiment to show that the ratio V by I is constant for a conductor. Explain the procedure of the experiment. First we have to write Ohm's law for that one, definition. Under the similar conditions of temperature, the potential difference across the conductor is directly proportional to the current flowing through the conductor. And circuit diagram we have to draw like this. I am connecting the voltmeter parallel to the circuit. I am connecting the ammeter series with the circuit. Ammeter is always connected series. Voltmeter is always connected parallel to the circuit. This conductor and connecting wires and a switch for on or off. Now, in order to verify this, I am drawing one tabular form. In that, serial number, current strength in ammeter, ampere, in amperes, voltmeter, voltage readings we will get 1 volts, and I take the ratio. In every case, I take 1 to 3 readings. Voltage to the current ratio will be constant, no change. So here what does this arrow mark denotes? Variable voltage. I am changing the voltage values and corresponding current values I will note down in the ammeter and form a tabular form. This is the procedure. And required materials he asked in the question. A battery, it is a source, ammeter used for measuring current strength, that you have to write all these things. Connecting wires, usually copper wires, conductor having non-zero resistance values, in which current increases linearly with the voltage for conductor. Voltmeter, in which we note down the voltage values, key on or off. Voltmeter, we take the voltage readings or PD across the conductor. So conclusion, what conclusion we got? Voltage to current ratio is always constant. That's all. This is the answer. We have to mention all these points. Next, ninth question. A circuit is shown in the picture. Current is passing through A is I. What is the potential difference between A and B? Here we have to mention, first of all we have to mention KCL, KVL, Kirchhoff's Ohm's law or Kirchhoff's voltage law we have to mention. Its definition we have to write. The algebraic sum of potential differences in a loop, in a closed loop, is always 0. So between the potential difference between A and B is also 0. Next, what we have to find? Equivalent resistance is asking. So 1 by R, there the resistors are in parallel. 20 ohms and 5 ohms are in parallel in the first case. As we have CD, there is a CD wire, it is dividing the 20 ohms and 5 ohms. So they will be in parallel. For that we are writing the formula R1 R2 by R1 plus R2. Next, again in the second case also the 20 ohms and 5 ohms are parallel. We will get 4 ohms. 4 ohms. 4 plus 4 we are doing because they are in series. We are adding up. We got the equivalent resistance. R equivalent we got. Now we know Ohm's law. According to Ohm's law, V is equal to IR. So the current is I when it is flowing from A, point A. It is divided into I1 and I2 values. I2 is the current flowing through 20 ohms. I1 is flowing through 5 ohms. So now what we can say? They are parallel, as already said. 20 ohms is parallel to 5 ohms. As they are parallel, then what we can say? A potential difference must be equal. VA, VD. This potential difference must be equal across the resistors. PD value will be same. So that's why I have equated VAC is equal to VAD. So VA minus VC is equal to VA minus VD. VA get cancel, minus cancel. VC is equal to VD we got. VC means here what is this? At C point what is the resistance? 20 ohms. 20 ohms is the resistance. Okay. So what do we do? We take I2 is the current flowing to 20 ohms. IR, V is equal to IR. So we can write I2 into 20 is equal to I1 into 5. I1 is equal to 4 into I2. I is equal to I1 plus I2. So from this we get I2 is equal to I by 5. I1 is equal to 4 times I2. So 4 into I by 5. Next, I want the current through CD. So what I have to do? Here the current is flowing in this direction, I2. I1 is flowing in this direction. So they are opposite to each other. So I dash must be equal to I1 minus I2. 4 I by 5 minus I by 5. I dash is equal to 3I by 5. Is the current through CD. Like this we have to solve the question. Thank you.